Alright, last one, putting it all together. Really common question in the exam. Give us two functions here, f of x and g of x. There's a little bit of restrictions here that you need to pay attention to. X is greater than or equal to 0 for this f function, which is just a linear equation, and for the g function, x is not equal to negative 7 over 2. Part A, solve the equation g of f of x equals x. So we need to form the composite function g of f of x. So g of f, remember we've got to do the inside first. We've got to go g of f of x is g of 2x minus 3x, that's the function, and then we've got to substitute 2 minus 3x into that g function wherever we see x. So the g function is just x plus 2 over 2x plus 7. So you can see we've just substituted x with 2 minus 3x. Expand the top and bottom, gives us this function here. And then the question just says, when is this equal to x? So multiply both sides by 11 minus 6x, expand the brackets, we've got a quadratic equation, move everything onto one side equal to 0, divide both sides by 2 because we can, that's nice, and then factorise that quadratic. I can tell you that all of these, the quadratics will always factorise. You won't have to use the quadratic formula. So if you're good at factorising quadratics, this will help here in this example here in functions. And we get x equals a third or x equals 2. Just make sure, if you go back to the original functions, that there's no problems with the x values here. So remember, this f function here was only defined for x values greater than or equal to 0. So both of these seem to be okay. Part B says express the inverse function of x and g in terms of x. We just got to find the inverse functions. So remember, that's just done by swapping the x and y values around. So for the first one, x is equal to 2 minus 3y. Swap the x and y values around, and then we're just trying to get y on its own. So add y to both sides, subtract x, divide by 3. So there's the inverse function, 2 minus x over 3. The other one's a little bit harder, a little bit trickier. Swap the x and y values around gives us that. Multiply both sides by 2y plus 7. Expand the left hand side gives us that. Remember, we're trying to get y on its own. Now this is the tricky step here. Bring everything with y over the left side, everything with x over to the right side. So now we've got two terms over here on the left that have y in them, which enables us here to factorise y. We then divide both sides by 2x minus 1, and that is the function in terms of x. So g to the minus 1x, 2 minus 7x over 2x minus 1. Part C says, show that the equation g to the minus 1x equals x minus 4 has no real solutions. So that is this one here. So this one here equals x minus 4 has no real solutions. So let's look at that. So that's this thing here. 2 over minus 7x over 2x minus 1 equals x minus 4. So multiply both sides by 2x minus 1. Expand on the right hand side, we've got a quadratic here. Add 7x and subtract 2 gives us this thing here. So divide by 2 just makes it a little bit easier. So in order to show that this equation here has no real solutions, we can show that the discriminant is less than 0. That's the important thing. So the discriminant here, A is 1, B is negative 1, and C is 1. So b squared minus 4ac will give us negative 3. So the equation, because the discriminant is less than 0, the equation has no real solutions. Part D asks for find and simplify an expression for f to the minus 1 g of x. In other words, do g of x and then the inverse function. If you're thinking of this in terms of functions, we do g of x first, and then after we do g of x, we apply the inverse function to whatever we get out of there. Alright, so we go from here, input a number into here, take that number, input it into this one, and then we get our result out here. That's what that looks like. Okay, but we want to find and simplify an expression. So expression means we want an algebraic expression out here, not numbers. So remember, starting from the inside out, so g of x is x plus 2 over 2x plus 7. And the inverse function we worked out for f in part B, that was just 2 minus x over 3. So we just replace x with x plus 2 over 2x plus 7, and that gives us this step here. Using a common denominator on the top line gives us this top line here. We then expand and simplify the top line, giving us this. So we've got 4x plus 14 minus x minus 2, then continue simplifying the top line here, giving us this step here. And now if you have a fraction, so if you have a half divided by 3, it's the same as a half divided by 3, that's going to be 1/6, isn't it? So if you have 1 over a divided by b, that's just 1 divided by a times b. So again, a bit of fractions here is needed to get to this step here, where I've just done 3x plus 12 over 3 times 2x plus 7. And then we can factorise common factor of 3 for both of these, so we end up with x plus 4 over 2x plus 7. Last part here, sketch in a single diagram the graphs of y equals f of x and y equals f of minus 1x, the inverse, making clear the relationship between the graphs. So that last bit is just asking you to make sure that you, on your graph, draw a dotted line for the line y equals x. So you can clearly see that one graph is a reflection of the other in the line y equals x. So the original function is y equals 2 minus 3x. So that's got a gradient of negative 3 and a y-intercept of 2. So that is the red line you see on this graph here, gradient negative 3, y-intercept of 2. Now you can go the algebraic way, and we've already worked out what the f to minus 1x is, but probably easier is to just do the point method that I've got here. So you know on that line, for example, that 0, 2 is on the original line, there it is there. So you know therefore a point on the inverse will be 2, 0, that one there. A point on the original graph is, let's pick another one out, 2, negative 4, that one there. So 2, negative 4 is on the original graph, so negative 4, 2 will be on the inverse. And I've got a few other examples there of how you do that. Negative 1, 5 is on the original graph, there it is there. So 5, negative 1 will be on the inverse function, 5, negative 1, right there. So once you've got 2 or 3 points, I've done 3 there, you can certainly then just draw a straight line through those points, and that is the graph of the inverse function.